So I'm going to talk while y'all are writing this down. We're going to write quadratic functions in vertex form. So we're used to a quadratic equation looking like ax squared plus bx plus c. That's how we're used to seeing it. So then we have to graph it to figure out what its vertex is. Well, it turns out that we can write them in a form that will allow us to determine the vertex just by looking at its equation, which we couldn't do before. We could figure out the axis of symmetry, which was part of the vertex, but figuring out the y-intercept, then we had to plug it in. In vertex form, what we're looking at here, y equals a times x minus h squared plus k. H is the x-intercept of the vertex. K is the y-intercept of the vertex. Now notice this minus sign right here. And this h is positive, so you change the sign on the h. So for example, if that were x plus 2 squared, x plus 2 in the parentheses, then negative 2 would be the vertex. So let me give you just an example of a parabola in vertex form. Okay, what I've got there in purple, y equals negative 2 times x minus 3 squared minus 4. The vertex is at positive 3, negative 4. Because it was x minus 3, I change its sign, so it's positive 3. The number on the end, I don't change. So the 4 stays negative there. Positive 3, negative 4 is its vertex. And I can go ahead and tell from this equation that that is a maximum because a is negative. Remember, we talked about that way back in the beginning when we were first talking about quadratic equations. When our leading coefficient, when a was negative, that parabola is going to be facing downward or opening downward. So you hit a maximum point. So vertex form is handy for being able to tell whether it's a maximum or minimum and what that is just by looking at the equation. Now, to take something from standard form to vertex form, we're going to use completing the square. But we're not going to move the constant term like we did when we were solving. And we're going to subtract that c instead of adding because it's on the same side. Okay, you'll see what I'm talking about when we actually do one, but I just wanted to go ahead and throw that out there for you to write in your notes. Okay? So we're going to take something that's in standard form, and we're going to put it in vertex form by completing the square. All right, so here's our example. Y equals 2x squared plus 12x plus 26. 2x squared plus 12x plus 26. So we're gonna go through our steps of completing the square. A is not 1, so we factor that out. X squared plus 6x, but I don't take it out of the 26. Remember, when we were completing the square, we moved that constant to the other side. Well, we don't do that in this case. Okay, we do not move it to this case, or move it in this case. We just keep it outside of our parentheses, and we don't change it for now. Okay, so factor the 2 out of the first two terms, out of the x terms, leave the constant alone. Okay, complete the square, so divide 6 by 2, we get 3. 3 squared is 9, so I add my 9 inside my parentheses like I always have, but I got to keep it balanced. It's on the same side, so I've also got to subtract, not 9, but remember when we had a GCF, we had to multiply it. I'm going to subtract 18. So here's my vertex form. Factor x plus 3 squared. 26 minus 18 is 8. So my vertex is at -3, +8. This one is a minimum because A is positive, so it opens up. So that's a minimum. Guess what? You can check it. Plug your equation into y equals the original equation. 2x squared plus 12x plus 26. Plug that into your y equals. Hello. Yes. Well, Mr. Hyde's going, just knock on the door. Okay, 2x squared plus 12x plus 26. Okay, plug it into your y equals, graph it, and looky there. My vertex, I'm not going to check it exactly, but it looks like -3, +8. Okay, -3, +8. So, the reason why I'm showing you this, okay, and I know this is several steps to this process. If they just ask you what's the vertex, type it in your calculator, find the minimum. Okay, there's nothing wrong with that. You technically don't have to do this, but I have seen them ask questions where they kind of ask you, well, what would be the next step? So I'm showing it to you so that if you remember how to do it, you could answer a question like that. What's the next step, or what's missing, or where's the error? They have started asking questions like that. Okay, let's look at one like number 2. Okay, let's look at one like number 2. Y equals -2 x squared plus 7. Well, this one's actually a little bit of a trick question, kind of, sort of. There's no x, okay? There's no just plain x. We've got x squared, but we're missing the linear term with the x in it. We can't complete the square if there's not an x. So, let me see if I can kind of sort of write it in vertex form here. It's kind of like this. Okay, that's the same thing, because if you subtract 0, you haven't done anything to it. Okay, so this vertex is 0, +7. Is it a maximum or minimum? A maximum. A is negative. It's a maximum. Okay, so I wanted to throw that one in there just so we could see an example like that. And then let's do one more. Y equals -1/4 x squared plus x plus 6. Okay, we start by factoring out that coefficient in the front. Now remember, this is kind of the weird thing. Just take my word for it that when you factor out a -1/4, you end up with -4 in front of that x. You can check it, multiply back out. -1/4 times -4, negative times negative is a positive. 1/4 times 4 is 1. Okay, complete the square. 4 divided by 2 is 2. 2 squared is 4. So we add 4 inside of our parentheses. We multiply it by the GCF. 4 times -1/4 is -1. And so we subtract -1 from the end. So we've got -1/4 times x minus 2, minus sign, we squared 2, and 6 minus a -1, subtracting a negative is the same as adding a positive. So our vertex here is +2, Positive 7, maximum or minimum? Maximum. A is negative, so it's a maximum. Okay. Again, you can graph it. You can find the vertex. Okay. If they're asking you for it in vertex form, 1/4 x squared. Why did I put parentheses there? Because I'm trying to think about something else while I'm doing this. Okay, graph it. Find your vertex. Okay, 2, 7. Obviously, you would need to confirm that it may not actually be that whole number. Okay, go over here, press enter. Go over here, press enter again. Here it is, 2, 7. Now again, calculator. Estimating 2.0000. If you have that many zeros, just call it 2. Okay, just call it 2. The vertex is at 2, 7. If you can just remember, that if there's a number in front, that goes in front of your parentheses, and you change the sign of your x, and your y just goes on the end, you really take, if all they're asking you for is the vertex form, if you can remember those 3 things, the coefficient goes in front of the parentheses, change the sign on the x, keep the y the same, you've got it. You can use your calculator and you've got the vertex form. Or you have 4 answer choices. Graph the original one, graph your answer choices, see which one matches the graph. Only one of them is going to match. You got it there. You really don't even have to remember anything. Okay? So that's what I've got written here. You can graph the function, graph all your answer choices and compare, or graph it, find the vertex, plug it in to the vertex form. Just remember your x coordinate changes signs. The x coordinate changes signs. Okay, so I showed you the process in case they ask you something about a step of the process, but otherwise use your calculator. Be smart about it. Okay.